Assalamu alaikum. This is the second lecture of Discrete Homotopy theory lecture series. So in first lecture, we saw about the first section, preliminaries, and we saw the definition of graph and graph maps and some type of graphs, IN interval, I infinity interval. So in this lecture, we saw next some things about preliminaries and related to graph as well. So our first objective is n cycle graph, where for n is greater than or equal to 3. So what type of vertices? Vertices are integers modulo n, that is 0, 1, 2, 3, 4, 5, and so on to n minus 1 belongs to this quotient group, and we can say these integers belongs to Zn, okay? And edges I to I plus 1 for all I belongs to this quotient group, or we can say the Zn group, okay? So what are the examples of these group? So if we write a C3, so vertices are 0, 1, 2 according to this definition, 0, 1, 2 and minus 1. If we choose C3, so the vertices are 0, 1, 2, okay, and minus 1 vertices, 0, 1, 2, and edges are I plus 1, 0, comma 1. This edge name is 0, comma 1. This is 1, comma 2, and this is 0, comma 2 or 2, comma 1. We can say 2, comma 1. And these all belongs to this quotient group. Okay. Now I am going to the next concept, the box product of graphs. Okay. The box product of graph. So this is very much important topic in this lecture series, box product and the monoidal product of graph. So what is the definition of box product of graph? If two graphs, let's say, if two graphs x and y, so we can write the box product of graph denoted by x box product with these y, such that define as follows: x box product with y, the set of vertices are x cross y, means the Cartesian product of vertices of graph x and y. And what type of the edges set? So the box product of graph x and y edge set is like this. So means x comma x dash, sorry, x comma y, edge with x dash comma y dash, such that either x is related to x dash in x graph and y equal to y dash, or second condition is x is equal to x dash in x graph and y is edge with y dash belongs to the x y e, okay? So if one of these condition are hold, then we can say the box product define. Okay, how can we define the box product of two graphs? First of all, we will take the Cartesian product of the vertex set between two vertex sets, and then edge set. How can we make the edge between the vertices? If x is related to x dash and y is equal to y dash, okay? Otherwise, x is equal to x dash or y is related to y. So let's take example. So for example, I1 box product with I1, okay? So how can we box product with these two graphs, I1 and I1? So what type of I1? I1, vertices of I1. So vertices of I1. First of all, we required vertices of I1. So vertices of I1 is 0, 1. and vertices of I1 is equal to also 0, comma 1 because both graph are I1. Okay, so first of all, I1 box product with I1 equal to, according to the definition, I1 V of I1 cross V of I1 means we will take the Cartesian product. So what is the Cartesian product of these two sets? So 0, comma 1 and 0, comma 0, sorry, 0, comma 0 and 1, comma 0, and the last ordered pair is 1, comma 1. Okay, so we have four vertices 0, comma 0, 0, comma 1, and the next is 1, comma 0, and last is 1, comma 1. So according to the definition of box product, how can we make the edge if the first vertex, if the both ordered pair, first vertex should be equal or should be edge, and second vertex of each ordered pair should be equal or edge according to this condition. Okay, one of this condition is hold, should be hold. So if we saw this two vertex, so 0, comma 0 is equal according to the first condition. Second condition means x is equal to x, and 0, comma 1 are edge in second vertex. So we have a vertex. We have an edge between these ordered pair. Okay. Now let's check between these two pairs. So these two pairs 0, comma 1. So we have an edge in 0, comma 1 in x means this graph, and 0, comma 0 is equal. So and 0 is equal to 0 means y is equal to y condition, y dash, and x is related to x dash. So there is an edge in between these two vertex ordered pairs also. So let's check between these two pairs. So 1, comma 1, 1 is equal to 1. So first, second, this is the second condition, and 0, 1 is an edge between this graph y. So there is an edge between these two vertices. So let's check these two. So 0, comma 1, there is an edge according to first condition, and 1 is equal to 1. So this is the first condition hold. There is an edge is x. There is an edge between x and x dash, and y is equal to y dash. So there is an edge between these vertices. Let's check between these two vertices, 0, comma 1 edge, 0, comma 1 edge, no edge. And let's check these two vertices. So 1, comma 0 edge, 0, comma 1 edge, no hold these two conditions. So there is no edge. So there is a box product. We have a box product between two vertices, two graphs I1 and I1. So, okay. Allah Hafiz. I will explain further new topics in next video. Please join us, subscribe and share.